Okay, I'm going to go over the graphics code. So, in a recent video, I started talking about the graphics code. So it puts the background colors for the text. So those are 8x8 blocks. Puts the foreground. Now it can shift if you do superscript and subscript. It can shift the text off of the grid. If you'll notice, I just shifted that. That's a superscript. Anyway, so we can look at those routines. They're mostly assembly, I think, or something. Background. So basically it looks for the color. I write to a temporary, I write to a buffer that's not the actual VGA buffer. I think I do, I merge all, I put one pixel per byte, and I only use 4 bits. And then when I'm all done with the, I write to the temporary. Then when I'm all done, actually this line puts the persistent layer onto the buffer. Then it puts the GR final screen update, puts a mouse cursor, and then finally 30 times a second it no, not quite yet. I think it makes a right here it converts 1 byte per pixel to 4-bit planes. Then once it has the 4-bit planes, since screen memory is slow, it caches it and it only updates what's changed. So this only updates what's changed. You can set a bit to freshen everything. Once in a while the cache will get wrong and you have to update the whole screen. Oh, I forgot, I have zoom. Built into the screen is, or into the screen stuff is Control-Alt-Z. Zooms in on the mouse cursor. Control-Alt-Shift-Z zooms out. That's built in right here. So it turns out if you cache it, it's surprising that it doesn't take, well, anyway, it doesn't take that much CPU, all things considered. I don't know. So let me review. It sets the background to the like if you do F3 Control, I don't know, what's the Control I? No, that's not it. I'm trying to make a block, an inverted block. Control Z. Yeah, like if you make Alt F3, Alt F2, you can imagine blocks of background, and then it puts the foreground on top. Then this is on a byte per pixel image. Then it's updating the text and I was gonna sneeze. Anyway, there's puts a persistent layer. That's also a byte per pixel onto there. Then it puts the mouse cursor. Then it converts 8 bits per pixel, or well, 8. It converts a byte per pixel to 4-bit planes. Then it updates the graphics. Now you can run in text mode. That's almost never done. Anyway, so I guess we can talk about the graphics. So F1, graphics routines. So the first thing you have to know is, or not the first thing, control left drag will let you pan any window, including all the graphics. So there's some advanced features. Zoom, Control Alt Z, and pan. Those are built into everything. So let's go ahead and talk about. Should we talk about the 3D? I think the 3D is what we should talk about. So where should we start? We can talk about dither. Oh, I don't care. Anyway, there's a matrix. Then there's about 3 different offsets you can play with. There's an offset. We use a 4x4, so you have an offset. And we use a, in the device context, there's an offset of XYZ. And there's the pan. That's kind of another, you don't play with that. Anyway, so I actually have a, there's a video about this, about you doing 3D meshes that's built into the editor. So this is a first-person shooter. You can look at the code, learn how to do 3D graphics. There's a flight simulator. This uses 8 cores to render. We have a frame grabber that's not getting as many as frame grabber's getting 8 per second. Normally it's doing 30, and that's an extra load as well. Anyway, I'm tired. Let's see.